Welcome, everyone. Um, Today we are going to be talking about building secure software. Uh, Cybersecurity, every developer should know. And we are going to be talking about security when it comes to building software, hosting the software, giving it out. Since we are free and open source software community, I think one of the things we should know or should learn is how to handle software with care. So let's look at the first thing. We are going to dive right into it. The very first thing we talk about is the modern threat landscape. By the way, maybe I should define some terms. When we say a threat in this context, a threat is, let me see, a threat is anything which gives another person who is not supposed to be privileged access to some artifacts we have. So, for example, if someone gets access to a database, someone gets access to some passwords and some other stuff like that, then that's what we call a threat. And I'll just go over a few of these threats and then we'll just talk about them. The first ones we'll talk about are vulnerable dependencies. I'll try and explain this one. So, dependencies, what are dependencies when it comes to software? When you write software, most of the time we don't write everything from scratch. We take software from other people and then we use it in our code. So those software that we take from the other people are what we call dependencies. So now your software depends on someone else's software. And so you could have a software which is very secure, and if the dependency is not secure, the entire thing becomes not secure because then it means that the point of weakness is now from your vulnerable dependency. Uh, the next thing would be exposed API keys. So I don't know if any of us know what APIs are. The most simple explanation or the most simple way I have been able to explain APIs is that APIs are like we go to a restaurant and then the chef is in the kitchen and yet it is the waiters who go in and bring the food out. So that's the work of APIs. APIs allow you to access something behind the wall. So you just go to the API and the API goes inside the kitchen and brings you the thing. All right. So um, yes, so the API is the application programming interface. Yes, that is the technical term, but now we all understand what it means. The next thing is weak authentication. Weak authentication is just um, checking to know if someone is really who they say they are. That's what we mean when we say authentication. So when you're logging into Google, Gmail, passwords are one form of authentication. There's also other types of authentication like biometric authentication. We have what, fingerprints and iris scanners and all those stuff. Yes. The fourth one on the list we talk about is the SQL injection. SQL is a very popular database language. It's a very popular one. So SQL injection would actually be a broad term for all databases, and it's talking about being able to inject commands and feeding these commands to the database. That's what an SQL injection is. So let's say you have an application, it's taking input from people, and as part of the input, someone is able to put a database command, as part of his, for example, his name, and then he submits it. And so the thing goes to the database is working with the name, and yet it sees the command and it tries to run the command. So it can have very bad effects. It could drop your, when I say drop, I mean delete the entire database. It could leak information. So that's what the SQL injection is. The next thing we talk about is cross-site scripting, which is XSS. That's the name. You could call it CSS, unfortunately, that name has been taken by something else. And so we just put the X there. So that XSS. And what cross-site scripting is cross-site scripting is the ability for you to be on one site and then to run a script on another site. This is not supposed to be possible. And the reason is because every site, what we call a domain, that's what we call it. Every domain should be isolated in a sense. It should be in a sandbox. If one domain is able to run a script on another domain, then it can access some of the things of the domain. And the most important one, which I'll talk about, is the cookie. I don't know how many of us here have heard the word cookie before, but I remember back in the day I used to watch my phone and I'm like, what is this cookie thing? Basically, cookies are tickets that servers used to remember us when we access sites. So if I took my phone right now and I was trying to log into Facebook or Instagram, I don't have to log in every single time. And the reason is because I log in once and then I'm giving a ticket, which is called the cookie. And once I get that cookie, anytime I'm coming in, I just show my ticket and then they're like, oh, okay, it's you. Then you come back in. But then this also means that anyone can steal your ticket and then impersonate you. Most people, when it comes to cybersecurity, think that their passwords being compromised is, let me say, the main way that they are going to lose stuff. So they hide their passwords. But usually you don't need the password. If you can just grab the cookies, you can use the cookies to impersonate the person. It's that easy. Then the other thing would be insecure file uploads. So what are insecure file uploads? When you have a server, you are accepting files from people. So files being sound, pictures, videos. One of the things that because they are all data, they are all zeros and ones. So instead of the thing being a video, you could ask for a video and someone could give you a virus instead. And if you are writing your code and you don't make the distinction that make sure that the thing is a video. I said ask for a video from the person. If the person gives you anything else apart from the video, don't take it. If you don't write it that way and ask your code to do that, then your code is going to be taking things from people. Some of them, like I said, viruses, and by the time you realize the thing has messed up your entire system. Then the last one, misconfigured cloud services. This one is, I would use the word relatively new, but it's not relatively new because the cloud revolution began a long time ago. But for those of us who have, or let me say, who are running systems in the cloud, it happens that we have to connect the cloud endpoints. It's not your machine, it's your server, but you are renting it from someone. So somehow there has to be a way for you to be able to connect it so that anywhere you are on the web, you can still go to the same cloud provider. And the thing is that sometimes when we are working in, usually work in two modes. We say we are working either in development or in production. Development is where you can play around with your code. But then once you are going to deploy it and serve a group of people, then that's what you call production. So the thing is that coding in development is more free because you want to catch bugs and stuff. But usually when you are pushing to production, it's expected that you would have caught all your bugs. So all these unsafe features have to be removed. And sometimes we as developers can forget to do these things. And then by the time we realize someone else is able to access something which we were not supposed to. So we'll talk about some common developer mistakes. One of the most common ones is hard-coded secrets. The reason why I bring this in is that if we know of, I'm sure we all know of Git and GitHub. Yes, it's very important I make the distinction. GitHub uses Git, but it's a big place where you can host your Gits. Let me put it that way. And the thing with GitHub is that other people are able to look at your code and see your code. So when you can see over here API key. API key is more like in this example, API key is more like a password which you have. In fact, the main way I can link what the API key in this situation is to what I have said before is when you have the waiter, when the waiter comes, you sort of show them that, oh, I've paid. Where's your card? Where's your ticket? That shows that you have paid. If you don't, you cannot just call a waiter and tell him, go and bring me this, and then he goes and then he brings you the stuff. He will have to see that maybe you came for the party, and so then he's going to serve you or something like that. So in software, we have API keys which we use, and it's supposed to limit the access to the API so that not everyone can have access to that information. And sometimes when we are pushing our code to the cloud where other people can see it, we can make the mistake of hard coding the secrets in the files. And when you do that, then it means that everybody can see it. Now, one of the things about Git is that Git does is it version control. Anytime you publish something to Git, the old thing you publish is not deleted. It is just sort of archived somewhere, and then the new thing comes. So if you make a mistake like that, and then, for example, let's say I commit this, I push it, and I realize, oh, I made a mistake. So I go and I change it. Even though I have changed it, that old version is still there. And people can still go back and look for these API keys. In fact, even now, there are tools that are walking around looking at GitHub repositories for these particular mistakes that people have made. Yes, yes, but. So yeah, for these sort of things. Over here, you see, I give an example where I say instead of hard coding this in the file, so API key is ABC123. What you can do is you can use and this is Python. So os.getEnv. So getEnv is you are getting an environment variable, and then you get the API key from the environment. If I should try and explain what the environment is just you can think of it as the way you set up your, how you like your machine to be. That's the closest I can get. So in your environment, you can have so many variables. You can see so many variables in your environment. But the point is that because the environment is separate from the file, you can, because the environment also lives on your machine, you can keep those passwords and those secrets in the environment. And then when you push it out, it doesn't go with the file. The next thing we talk about is user input. So when you are taking input from a user, one of the things you should do is you should not trust inputs that comes from users. Don't trust, number one, URLs. Where do you want to go? Take me to this site. Then somebody is typing a site. Forms, cookies, JSON, which is JSON, you can see. It stands for the JavaScript object notation. It's a way of, we say, serializing data, which is to, when you're going to send data to someone, you have to package it very nicely, and then you send it to the person. So that's what it does. So, and then headers, so validate everything. This one is more under when someone gives you something, one of the things you want to do is you want to check that the thing is safe before you even handle it. So you could say, give me, there's this, I'll give an example. There's this one time I was with someone who was, starting out coding and he was doing his stuff. And it was it was something like a calculator, which what it would do is it would ask for a number, give the number, it takes the number, it adds it. Something very simple. And so he's looking at the thing and he's happy. So when he's not looking and I try the thing out, but instead of giving it a number, I give it like some asterisks, and because it's not a number, the whole thing fails. There's some division by zero somewhere, and like everything just crashes. Usually, when the person came back and then you saw the thing, it's like, oh, okay, nothing, but it was just a crash. And that's what you think. You think that, oh, this is just a crash. But in cybersecurity, which is in the what people call black hat cybersecurity, everything is used, including crashes. So a crash may look like a normal crash, but a crash can be a denial of service attack. If I can feed your online what code, I can just give it some code and then it can crash. Then I can write a script that will just repeat it, keep crashing you, and then your customers are not able to access the thing. If it was a firewall and I was able to crash it, then like that one is even worse because then you don't have any protection at all. So it doesn't matter whether the thing is crashing, whether it's not crashing. If it's misbehaving, you should check and see that whatever you've written in your code, number one, is handling the input well, and then you are making sure that the input which the user is giving you is the right kind of input. Then I gave the example with the username, with the SQL injection. So this is an example of SQL. So it's a programming language very synonymous to English. You can see select star. I'm sure you can see the asterisk. I call it star, but the asterisk means select everything from users, and users is the name of a table in the database. So it is saying, okay, go to the users, select everything where the name is, and then you put the name of the person over there. This is just a simple substitution. It's just saying take this command and then join the person's username to it. I'm sure we can see that. But the thing is that at the end of the day, when you join the username, the whole thing becomes a command. So what it means that if I was giving my username and I put a command as part of my username, then that command will also get run. I don't know if we understand what I mean. Yeah. Okay, so the good way is to use parameterized queries. That I would have to, let me say, show it. But basically, we have what we call escaping, and escaping is for characters which are, I don't know if I should call them, they are sensitive characters. So examples of these characters are semicolons. Anybody who has done programming would know that. Anybody who has done programming would know that a semicolon can do you harm if you leave a semicolon somewhere. So if someone is giving you the name or something, and you put a semicolon in there, all of a sudden your thing is crashing, then you have to take care of it. So in some sense, that is what we mean when we say the thing is parameterized. XSS, I don't know if you remember, but XSS, like I said, means cross-site scripting. So when you are able to run a script, and by a script, I mean JavaScript. So when you run JavaScript on a site, and then you can pick stuff up, escape or sanitize everything. So if we look down here, you can see it. My name is, and then you can see a script tag and an alert function. This is what I mean when I say that if the thing is going to be used as a command, if someone can put a command as part of their own input, then all of a sudden the command is run. If we look here, we are going to see two script tags. This is the opening script tag, that's the closing script tag, for which is HTML. And then over there you see a function which is called alert. And then if you look very closely, you see what it is: document.cookie. With just this, you have access to the person's cookie. It's as simple as this. It's not very complicated. Just this one line of code is enough to pick up somebody's cookie and just log into their account. So this is one of the common mistakes that we make. For our next slide, we'll also go over more authentication mistakes. Number one, don't store passwords. When you are taking usernames and passwords from people, don't store the passwords. I'll just make this a little open and ask, why do you think it's not good to store the passwords of our users? You can just go in there. Yes, you can just go and pick it. Another thing would be that many people reuse their passwords across different sites. So even if they pick it up, then it means that you just help to compromise the person's whole life. Number two, don't invent your own crypto. When I say crypto, I have to be very specific. I don't mean cryptocurrency, I mean your own cryptographic hash functions. Yes. So don't invent them. And the reason is that the cryptographic hash functions we use right now, they are top cryptographic hash functions. And they are the best that we have to offer. In fact, a lot of them go through a selection process and a lot of them are rejected. Usually it's just one or two that will be picked. If you ask what are the top crypto functions that we have right now, you could actually mention them. Oh, SHA, this. You could literally mention them. And it's not that there are not other crypto functions or cryptographic hash functions. But the point is that all of them are not that good. And so they've been thrown away. If you try to invent your own crypto with your bachelor's in science, try to invent your own cryptographic hash function. It would, I mean, I know there is a chance that probably would hold, but 99 out of 100, it will not be a very secure cryptographic hash function. It's much, much better for you to use what we have currently. Then the other one is don't use MD5. I don't know if any of us have heard of MD5 or SHA1. So SHA stands for the secure hash algorithm. And you can see the one there. The one is that's the first iteration of SHA1. The second was SHA256, something that Bitcoin uses. And then the third is SHA, I think 386. So don't use them. And the reason why we say don't use them is that when they were built back in the day, they were not very, they could hold their own. Right now, they don't hold anymore. The machines and the GPUs and things we have, MD5 and SHA is too easy for them to crack. So when you are doing, in fact, there are some examples that we have here, some newer ones for hashing functions, Argon 2, Bcrypt, which personally I've worked with before, and then Scrypt. These are all much better alternatives to MD5 and SHA1. Then let's talk about dependency security. Just like we mentioned at the beginning, modding software isn't just your code. A typical project can have 500 plus, 1,000 plus, or even 10,000 dependencies. When I say dependencies, I mean they are just software which your code relies on. There's a whole lot of software at the back that your code is relying on. And so, because of this, one of the things, in fact, NPM, how many of us know what NPM is? So, NPM is the Node Package Manager. So, anyone who did or who has worked with Node.js, which is a programming language, JavaScript, would know what NPM is. And the pip, let me see, Madam Bridget, we did some pip install the last time up there. So that's for pip being for Python and cargo for Rust. So you have NPM audit, pip audit, and then cargo audit. And these are they are audit commands that you can give to the package managers. And what they do is that whenever a dependency has a vulnerability, they will check those compromised version, and then they will check your code base, and then they are going to check if you have the compromised version in your code base, and then they'll tell you that, oh, this particular dependency you have is obsolete, it has been compromised, don't use it. So running NPM audits or pip audits and cargo audits are, let me say, they are tools which would help you to find these vulnerabilities. The other thing is to keep dependencies updated. We've also heard this thing a lot in the software community, where there is software, legacy software, which has been working for so many years. And yet, because it is working, we are not going to touch it. But the thing is that as we keep going day in, day out, we're going to realize that because there are a lot of updates coming in, and the updates are supposed to make the things better, are supposed to make them run faster, and then they are supposed to make them be very secure. So if you are not updating, then you are leaving yourself at a risk. Then secret management. When I say secret, I'm talking about passwords, I'm talking about tokens, I'm talking about API keys, database passwords, SSH keys, certificates. I think I demonstrated the last time with Mr. Santo. And then JWT, the Java Web Tokens. So JWT secrets, which they are all forms of, to the layman, they are all forms of passwords that we use. So when I say never commit, I'm talking about never put them on the internet. Don't push them along with your code base. And in the beginning, I gave an example. So you can use environment variables, and then you can have secret managers. So an example of a secret manager is a password manager. I've never used a password manager. I know Chrome has one inbuilt. Firefox also has one inbuilt. So when you log into a site, it can generate the password. Oh, none of us have used one. Yeah, nice. All right. Then CI and CD secrets. So let me see. Okay. So CI and CD. CI stands for continuous integration, and CD stands for continuous delivery. And to be honest, CI is something that I met myself, which is I know of it in theory, but I just started working with it last week. And what CI does is, I think, is one of the very best things have ever happened to our code bases. But with CI, what happens is that when you write software, the software is so continuous integration. The software is immediately integrated by a script. So you have a script, you put a script there. As soon as you make some changes, the script runs. It takes your code, it puts it in. With CD, continuous delivery, it's going to package the software and get. So as soon as you make any changes in your code, the changes are made, and then a final version is just brought out to you on the spot without you having to run it at home, and the dependency issue, and it works on my machine. Why is it not working on your machine? This CI and CD handles it very nicely. Then we can talk about other secure development practices. So I would say that security begins during development. You cannot finish writing your project and then come back and say, okay, I want to check if the thing is secure or not secure. As even from the beginning, as you are writing, you're supposed to be thinking about it. So when you are reviewing code, you shouldn't be thinking only about the styling and the formatting. I know because my professor really punishes when you don't indent your code to make it look nice. I, for one, don't like doing that. I like to keep it confusing. But basically, we shouldn't only review our styling and our formatting, but then we should also review authorization. Is this person allowed to have this file, have access to this file? Validation. This thing that you're giving to me, is it what I asked for? Error handling. If there is an error, I should be able to tell the person, oh, there's this error. In fact, one of the things I will do is I will give an example with our, okay, maybe I shouldn't criticize it. Yes, but basically I used something to register, and there was an error on the back, and the thing was just failing. It just tells me failed, failed, failed. And if you let me know the error, I could have, try and see if the error is coming from me or it's coming from the other end. When you have generic error messages, then you're going to just run around and then not know what you're looking for. Then logging. What do I mean when I say logging? Logging means everything you are doing, we are writing it down, we are recording it. We should also review logs and secret. Secret, like I said, you can think of as passwords and stuff. Then let's look at logging. When we are logging, like I said, logging means everything you do, we are writing it down, and then we are keeping it so that in case something goes wrong, we know who to blame. So when you're logging, one of the things you shouldn't do is you shouldn't log passwords, access tokens, and credit cards. I just spoke about this with someone, and the most direct one is credit cards, because one of the biggest, let me say, problems we face in this age is credit card fraud. And the reason why there is credit card fraud is that the credit cards are locked. When you buy something from some sites, they don't just throw the number away, which is the credit card that you use for the purchase, but then they keep it. And so when they are compromised in the future, then all of a sudden your data is with some people. And so that's what we mean when we say there are certain things that you should not log. However, when you are logging, one of the main things that you should log is when there is a failure, something went wrong, log it, which is save it somewhere so that someone who knows his job can come and review it and then tell them the reason. And the other thing is log suspicious request. So if you reject a request, you should log it so that we can know that, okay, maybe this is a cyber attack. If a human being can see it, right now we have the AI tools which are helping on that end. And then we can also log authentication attempts, which is what happens when you try to log in, you get something wrong, and it says that you can only log in 2 more times because it's keeping count of your failed login attempts. So these are some of the things that you should be logging. One of the most important things for us to know or to note is the principle of least privilege. And the principle of least privilege means that only give people the permission they need. Don't give them permissions that they don't need. So the example is a web app should not have root access to the database. And what I mean by this is that as developers, we sometimes have a lot of projects running. So the database, we just have one database on our machine. So if all of them have root access to it, all of them should not have root access to the database. They should all have access to their parts of the database. They shouldn't be able to have access to other people's parts of the database. And this is what we mean by the principle of least privilege. The best way I can give an analogy is that if you are in a hotel, every customer of the hotel should only have access to their own room. They shouldn't be able to walk around and enter other people's rooms. That's what we mean when we say the principle of least privilege. So everyone has only what they need, and then in case they we need to go further, then we upgrade and then we give them something else. Then CI/CD, like I said, continuous integration, continuous delivery security. Many attacks are now targeting pipelines. So we should secure, like I said, GitHub Actions, GitLab CI, and Jenkins. GitHub, GitLab, I'm guessing every dev here would have used it at some point. But what they host your code for you. That's the main thing. Jenkins, no, not Jenkins, but just GitHub, GitLab. All right. Then let's look at CI/CD security. Like I said, we should protect our secrets, our artifacts, and I like this one very well. Signing keys. Now, what are signing keys? Unfortunately, I have to do some small cryptography over here. But basically, encryption today is based on, I shouldn't have said encryption. What we call asymmetric cryptography. And asymmetric cryptography is like this. So in the past, the way we used to encrypt our stuff is just the way we use the door. So you have a door, you have one key. The key you used to open the door is the same key you used to close the door or lock the door. Let me say it like that. So you go out, you lock the door, when you come back, and then you lock it with the same, and then you open it with the same key, right? But then what asymmetric cryptography does is that it gives you one key that can open the door and another key that can lock the door. So if I wanted to send a message to someone, then what I would do is that I would let's say I'll give my opening key to everyone. Anyone who wanted to receive my message would get the opening key. But then I would keep the closing key and I'll keep it safe. So if I wanted to send a message to someone, I'll take a box, I'll write my letter, I put it inside, and I lock it. And then when you get it, you say, oh, okay, this is John's key. Then you take John's key, and John's key is the only key that can open that thing. Once I lock it in there, my key, which is, I told you I have two keys, the one that opens and the one that locks. So that particular key is going to be the only key that can open it. And that is how modern day security is based. So what happens is that when your key is leaked to someone and the person is able to impersonate you by either locking or opening your messages, then you are in big trouble. The most the most the most direct example I can give is when you run programs. Uh, Unfortunately, I have to do a Windows example. You can run some program somewhere and it says, "Are you sure you want this app?" The user UAC, which is user access control, and then it will show you this is by Mozilla. The way it knows it's by Mozilla is that the key which was used to sign the binary is from Mozilla. So if Mozilla loses their key, then it means that somebody can write some virus, sign it with the Mozilla key, and it will look as if it came from Mozilla. So that's why we say protect your signing keys. And then the other thing is require pull requests. This one, if you've used GitHub, you know it. So a pull request is someone has a code base. If you want to work on it, you fork the code base, which means you make a clone of it, you work on it, and then you ask them to put it back into the mainstream. So that action is what we call a pull request. You're asking them to pull it back into the mainstream. So reviews. So reviews means we are not just going to use it. We are going to actually go through the thing. We are going to comment on it, and we are going to ask you, "Hey, what is this? Is this supposed to be here?" We are not just going to let you write anything you want. And then branch protection. Branches are just like I said with the pull request. Sometimes you get a code base and two people want to go in two separate ways. Some people say let's use this, some people say let's use that. So what would happen is that you get a branch just like a tree has branches, whereby they are working on a slightly modified version of the thing, and then there is the main stem. You can have many branches, but branch protection is just saying that when you have to integrate something and then you're not really sure, what you can do is that you can just put it in a branch so that in case if you're not sure, in case something goes wrong, then it's the branch that you're like, oh, okay, so this branch is didn't work. But if you put it in the mainstream, then you have a big problem because that's what everyone is going to. Then I think this will be our last but one slide. So security mindset. You should always be thinking like an attacker. I know we have some chess people here. So yes, you should ask yourself, if I wanted to abuse this endpoint, what would I do? As you're moving, as you're writing your code, you're asking yourself, can I bypass this authentication I'm setting up? Or you can even ask yourself, what do I need to do to bypass the authentication? Can I upload malicious files? Can I change another person's data? Can I send unexpected input? And then the last one, can I overwhelm this endpoint? This is like a DDoS stuff, which is denial of service. Can I send a large number of, by the way, DDoS, from the API example I gave you of the servers in the restaurant, DDoS is hiring a group of people to go and sit in the restaurant and waste everybody's time so that the real legitimate customers will get fed up and then they will not be able to come. That's what the DDoS is. DDoS, just for anyone who wants to know, stands for distributed denial of service. So you are denying denial of service. You are denying the service of the people. Then, so here is our checklist. Every project should have these things. So we should have HTTPS. I'm very sure we can all say what the HTTP means, but who can tell me what the S means? Yes. So the S in HTTPS is secure. So HTTPS is HTTP secure, is the secure form of HTTP. You should always be using HTTPS. Then, like I said, parameterized SQL, which was, I would say, a little difficult to explain without giving an example. But when you're taking things, you should escape them and you should make sure they don't have bad characters in them. Authentication, which is logging in with passwords and stuff. Then authorization. Authorization means that even though you've logged in, there is something that you cannot touch. Yes, you've logged in, but you are like you are using the free version. And there's another premium version which, even though yes you have an account with us, but this stuff is for some other people. Then input validation. When you take input from your users, make sure that it is what you ask them for. Output encoding. When you are giving output back to your users, write the output in such a way that it cannot be misinterpreted as a command. That's what we mean by output encoding. Secure password hashing. We've talked about dependency updates. We've talked about security management. We've talked about the passwords and the password managers and stuff. Then logging. I've talked about all those attempts. We should save them somewhere. And then we should also do backups. This is something personal of mine. Anytime I have to, because of how high risk I am, anytime I have to work on something, the first thing I do is to copy the thing down. And then I know I am safe to set fire to my things. And then when anything goes wrong, I just delete whatever I've done and I restore it. I think backing up should be something that actually is something that every system administrator should do. But I think every dev should also do that. And now I'm signing off. I'll leave with some quotes. That security is not about making software impossible to attack. And the reason why I say that is because you cannot really secure whatever you are doing 100%. And the reason is because attacking depends on resources. So if someone has enough time, patience, data to attack you, then there's not really much you can do. If they have all of the computing in the world, you cannot run away from them. But what you can do is that you can make it harder for them to attack. You can make it so difficult for them to attack that they'll just look and be like, nah, these people are not worth the effort. And then the other thing I would say is that every line of code is a security decision. So as we write our code, I think we spoke about the mindset we should have when we are writing the code. Can I attack this? Can somebody give me bad input and then stuff? So this would be the end. And thank you for being here. And I would like to know if anyone has questions. All right. Anyone has questions? Yes. Give me a question. Yes, Jason, yes.